So what is an ellipse? An ellipse is basically, you could think of it as like a circle that you grab on two ends and just stretch it out. And it could be horizontal, or you could have a vertical ellipse. And that's the basic idea. It's like a circle that you have stretched out one way or the other way. Obviously, if you take a circle and you stretch it horizontally, the same magnitude as you stretch it vertically, then you just have a big circle. Still be a circle. Today we are going to focus on ellipses centered at the origin. Ellipses at the origin. So first off, what is an ellipse? The definition of an ellipse. So the definition of a parabola is the set of points equidistant from a line and a point not on the line, where we called the line the directrix and the point the focus. Circles, that's a set of points equidistant from a center point, and we call that center point the center, because that makes sense. An ellipse, that's the set of points in a plane such that the sum of the distances from P to two fixed points F1 and F2 is a constant. Basically, you have 2 points, which we call foci. Right there, foci, plural of focus. And the ellipse is set up so that for any point on the ellipse, if I take this distance and I add up that distance, okay, so the sum of those two is going to be exactly the same as if I have this point on the ellipse and I add up those two distances, which is going to be exactly the same as if I take this point on the ellipse and I add up those two distances. So the sum of those two distances is going to be exactly the same no matter where you are on the ellipse, which is the idea they're trying to get across in this picture, but I understand that that picture is kind of convoluted if you're just looking at it by itself. That would have been really weird.
But really good.
So, we have some more vocab to talk about now. We have an ellipse that can be horizontal or can be vertical. And all the vocab is exactly the same. It's just where they go changes if you're talking horizontal or vertical. In the idea of an ellipse, you'll always have two axes that go from endpoint to endpoint both directions, right? The fat end and the skinny end. The axis that is longer is called the major axis, and the axis that is smaller is called the minor axis. So hopefully that's fairly easy to remember. The longer one's major, smaller one's minor. They both appear in both ellipses. So the minor axis in a horizontal ellipse is here, in a vertical ellipse is here. Then we have vertices and co vertices. So in an ellipse, a vertex is one of the endpoints of your major axis. And a co-vertex is an endpoint of a minor axis. So the co-vertices, here and here, the vertices here and here. Okay? And then we have a center. And again, today we're going to focus on ellipses centered at the origin. So it's all the same vocab for horizontal or vertical. It's just a matter of putting it in the right spot. So here, the standard form for the equation of an ellipse, all right, horizontal looks like this, vertical looks like this. Notice they look very similar. We have x squared over a squared plus y squared over b squared equals 1. And so that's another important note, is that it always equals 1. Always. But notice it says a is bigger than b is bigger than 0. A is bigger than b is bigger than 0. That's the same in both. So what is the main difference between the standard form for a horizontal and for a vertical ellipse? It's where your a squared is, right? A is bigger than b. And in a horizontal ellipse, a squared will be the denominator for x squared. In a vertical ellipse, a squared is going to be the denominator for y squared. So whichever one has the denominator that's bigger, that's going to be what direction the ellipse is going. Right? If x has the bigger denominator, that's horizontal because x is the horizontal axis. If y has the bigger denominator, it's vertical because y is the vertical axis. Then our vertices, A tells us where our vertices are, because again, the vertices are the endpoints of the major axis. B tells us where the co-vertices are, and the foci, so the question we had earlier, how do you know where the foci are supposed to be? They are going to be plus or minus C away from the origin. And they don't tell you in this table how to get C, but C squared is A squared minus B squared. So here, what is an equation in standard form of an ellipse centered at the origin with a vertex at 8, 0 and a co-vertex at 0, 5? Now, they didn't ask for a graph, but I'm going to draw one anyway. There's a vertex at 8, 0. And we're centered at the origin, which tells us we're going to have another vertex at negative 8, 0. And this is our major axis, meaning this ellipse is horizontal, because the major axis is horizontal. We have a co-vertex at 0, 5, which means we have another co-vertex at 0, negative 5. And there is our minor axis. So then we can draw our ellipse like that. Again, they didn't ask us to graph it, but that's basically what this thing is going to look like. To write the equation, really all we need is A and B. So if you look at the formulas on the previous page, these are the 2 points they give us, vertex and co-vertex. We have 8 and 5. One of those numbers is A, one of those numbers is B. Which means A must be 8 and B must be 5, because if you look at the formulas on the last page, A is always the bigger of the two. Always. So if you know that 8 and 5 are A and B in some order, and you know that 8 is a bigger number than 5, so then our equation for our horizontal ellipse, x squared over 64 plus y squared over 25 equals 1. What are the foci of the ellipse with the equation 4x squared plus 36y squared equals 144? And they ask for a graph. So the thing to pay attention to here is that in the standard form, I made sure to point out, it always equals what? 1. The right-hand side of the equation for an ellipse in standard form is 1. So in this problem, I have to divide everything by 144. That's going to give me x squared over 36 plus y squared over 4 equals 1. So from that, I know that a squared is 36, so a is 6, and that b squared is 4, so b is 2. So we need to know c, and I gave the equation that c squared is a squared minus b squared. So c squared is 36 minus 4, which is 32. So c is the square root of 32, which is 4 root 2. So then where are the foci? The foci are at 4 root 2, 0, and negative 4 root 2, 0. And I know that the c should go in the x part because we have a horizontal ellipse. How do I know it's a horizontal ellipse? Because in the standard form, x has the larger denominator. And whichever one has the larger denominator, that is the orientation for the ellipse. So then we want to graph this. 1, 2, 3, 4, 5, 6. 1, 2. 2. So we have points like this. Where the foci for root 2, I believe that's in between 5 and 6. So those 2 points will be the foci. There is the graph of our ellipse. Okay, road racing tracks in the U.S. are oval, with an asphalt surface in the shape of an ellipse or flattened ellipse around a grassy infield. If an elliptical track has a major axis of 3,400 feet and a minor axis of 1,600 feet, how far apart are the foci? Now, in this problem, it does not matter if you choose to draw your ellipse horizontally or vertically. It makes zero difference. But you're going to have a major axis, you're going to have a minor axis. 1,400 feet. So my major axis from here to here is 3,400 feet. So this point is 1,700, 0. What is the length of my minor axis? 1,600. And so this point is 0, 800. So it's asking, how far apart are the foci? Let's just pretend the foci are here and here. So it's asking for this distance between the two of them. To figure that out, we need to know what C is. To figure out what C is, we have to know what A and B are. But we just figured that out. A is 1,700 and B is 800. So we use those to find C. C squared is 1,700 squared minus 800 squared. And what is 1,700 squared minus 800 squared? I believe it is 2,250,000. So what is C? It's exactly 1,500. So C is 1,500. So then we have to understand what C means in the context of the ellipse in general. How far apart are the foci? Again, that's this distance here. C being 1,500 means this point is 1,500, 0, and this point is negative 1,500, 0. So how far apart are the foci? 3,000 feet. They give us the graph of an ellipse, and this ellipse is really close to being a circle, but it's not. It's really, really close. This is a vertical ellipse. They give us the vertices, the endpoints of our major axis, telling us that A is 5. They give us our two foci, telling us that C is 2. They want the standard form of the equation, meaning we need to figure out what B is. And you can tell from the graph that B is going to be some number between -4 and -5, between 4 and 5. So we need to use the equation. C squared is A squared minus B squared. So 4 is 25 minus B squared. So B squared is 21, meaning B is the square root of 21. And I choose to leave B as the square root of 21 because, well, first off, you can always leave your answer as a radical, and that radical doesn't simplify, so we're good. Also, they asked for the standard form equation, so this is really all we're going to need, is the B squared. So my standard form equation is x squared over something plus y squared over something equals 1. I know that a squared, from what they told us, we know a squared is 25. We know b squared is 21. Which one of these goes here? So since we are dealing with a vertical ellipse, it's x squared over 21 plus y squared over 25. Again, the basic idea, if it's vertical, which this one is, the denominator of y squared has to be bigger than the denominator of x squared. So this is the standard form of our equation.